Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Solving question number 55 of Tro's chemistry, structure, and properties. And in this question, sulfur and oxygen form both sulfur for one sample and sulfur trioxide for the other sample. And when these samples decompose, for the sulfur dioxide sample, we end up forming 3.49 grams of oxygen and 3.0 grams of sulfur. And for the sulfur trioxide sample, we end up producing 6.75 grams of oxygen and 4.50 grams of sulfur. We calculate the mass of oxygen of sulfur for each sample and show that these results are consistent with the law of multiple proportions. So in order to solve this question, the first part is fairly easy. All we have to do is calculate the mass of oxygen per gram of sulfur. So we just take the mass of oxygen and divide that by the mass for each of these samples. And for the second component, we have to show that these results are consistent with the law of multiple proportions. So essentially, we have to show that the ratios, so upon forming these two compounds, that the ratio of oxygen to sulfur and that of oxygen to sulfur for the two samples, those are whole numbers, right? The first part of the question, calculate the mass of oxygen per gram of sulfur for each sample. Stated all we have to do is divide the mass over the mass of sulfur. So for the mass ratio of 1, the mass of oxygen, I'll just call it M1. Sample 1, we just calculate that, which is 3.49 grams over 3.50 grams. Right, and this, without doing much arithmetic, that should be approximately 1.00. For the second sample, the mass ratio denoted as M2, that's going to be 6.75 gram divided by 4.50 grams. And that, when solved, yields 1.50. Now, this question tells us to show that these results are consistent with the law of multiple proportions. So like I stated previously, for the law of multiple proportions, we just have to show that the mass ratio of these two samples are whole numbers, right? So the mass ratio of the first sample to that of the second sample, this essentially gives us 2:3. Since we attain whole numbers here, these amounts are consistent with the law of multiple proportions. That is, the result we attained for these two samples are consistent with the law of multiple proportions.